Well-structured and documented APIs are a pleasure to work with. And nowadays, the de facto standard is OpenAPI, which comes with a good methodology of defining your API interface first and only then constructing everything around it. When we look at API lifecycle, it always starts with API requirements. There could be API design phase, then writing the specification, and only then we do the server implementation, writing the client code, consumers, doing any documentation, mocks, testing, and this diagram kind of shows that. What's interesting is that following this path, consumers now don't need to know the implementation of the API. They can just rely on this common specification, which is written in abstract language, ideally simple, but it's YAML, so yeah, could be tens of thousands of lines of code, but as industry, we kind of got used to that already. In this practical guide, I want to walk you through some of the most important parts of architecting, implementing, and consuming the API following the OpenAPI specification. You can find the full spec on spec.openapis.org website. The spec itself is quite huge. There are a lot of corner cases and properties to define, but we'll try to go through the most important ones. There are a lot of tools built around OpenAPI, which I'll demonstrate you later in this video, kind of generators, web UIs, etc. But it's important also to cover the difference between API design and writing the API specification, because they're not always the same. Bigger teams should spend some time talking about the API design, how to call the resources, what resources actually should be present in the API, and it's always good to define some API user guide or maybe follow some existing one. For example, there is a popular API design guide from Google that you can follow that can tell you kind of how to call your methods, or how to form your resources, etc. But you can define your own one. You can also use Swagger UI, for example, to play with it, share it with other teams to demonstrate. This can be hosted locally. You can use this editor.swagger.io version. But yeah, let's get back to the spec itself. So the latest specification version is 3.1.1, and it's funny that it's quite fresh and kind of October 24th, and not fully supported even by some code generators, which is funny. I'll show you a bit later. So we will skip the introduction part, though if you haven't read this, please do. But we will jump straight to the OpenAPI schema, which starts with this OpenAPI object. That's your kind of root entry, and is defined in this entry point called entry point file, which is usually called openapi.yaml, could be openapi.json, and actually the name doesn't matter. You can call it with your own name. I'll show you later that you can also split it into multiple files, because what happens is usually these specifications end up quite big, and sometimes it's nicer to split them, though there are challenges related to that. OpenAPI object itself, remember it's YAML, right, or JSON. It has only few things required, which is the version of the OpenAPI, some information about the API like version, description, and then kind of we go into the tags, security, components, and paths. So let's start with the root level part. All right, so let's create the openapi.yaml file. So that's the required fields. We go to the server section, which is an array of domain names that your API is exposed. So this is really good for public APIs. For the internal ones, this is optional, but maybe so we'll run our API a bit later. Let's go back to our OpenAPI object and see what else can we add. Security is a really nice requirement object that tells kind of how should we do the authentication on our API server. We'll skip it for now. There is a list of tag objects that can be reused later, so maybe let's add tags. So here we can see a very basic OpenAPI specification, just a skeleton of it, but the most of our definitions will be in the next two properties, which is paths. These are our routes, endpoints, and then components, which are types and definitions of our requests and responses and maybe error messages and so forth. In the paths section, we will have operations that are grouped by these paths or endpoints. So you can have, for example, /devices/id, and there could be a post method for that, or patch, and then delete as well. So that's actually what I'll do it here, right? So paths is a map. So we start with, let's do devices, then it's a device ID, right? And now let's start with the first operation, which will be on the get HTTP method. It will have the following properties, and actually quite many: summary, description, all of that. So let's start diving in. So summary would be, say, get a device. Important property is the operation ID, which is a unique string defining your operation. It's optional, but it's really good to have it, and then you can use it in the server for login or making sure that you can check which operation ID is called. It's also good for communicating your operations in a unique way, because summary can be duplicated. Two endpoints can have the same summary, but operation ID is not. So let's do it get device, right? We can refer to our tags that we defined before. Since we have a device ID in the path itself, let's define parameters for that. So parameters would be and here we could define the type of our device ID. So we could put a type string here, but I usually prefer to define a separate type for all IDs in the system, or at least of kind of some subsection of our IDs. So in the future, we can change the format quite easily. So that's how we use schemas or components in the OpenAPI. So we can instead of doing string, we can do something like schema ref and reference something that doesn't exist yet, but we will come to that. Right, so components, that would be schemas. Let's, for example, use something like ulit for our IDs. Now, the next important property is responses, which is a map of HTTP methods. So let's define few, maybe 404. So let's do description. For example, in this case, could be something like success. What was that? Content, and then the type, I believe. And again, we can use we can refer to some schema that we'll define later. So we could write it here as well, but it's not really scalable, right? Because imagine you'll have multiple endpoints, list devices, create device. That would always work with some device object, let's say, that has a device name, device address, etc. So better to refer to some external types. Another cool thing about this responses section is that you can also provide an example, which is a good documenting point for whoever reads your documentation. It will be displayed in the Swagger UI if you use that. What's also possible is to move these parameters definition somewhere in the components section. We can actually do it maybe a bit later. But for now, we already have 3 types that we need to define, right? So, and they can be done here in the components schemas. But let's go back to the components thingy. It's a component object. It has many kind of sections here, right? And we'll be probably only using schemas for this exercise, but think about component section as all your types that can be reused in your application. That goes to, request payloads, right? In path or inquiry parameters, responses. Let's start with kind of simple one, maybe device. So here's a very simple type of device. We could go even further and split it into multiple subtypes, because usually, let's say the property name or device name will appear in multiple types as well, and you don't want to define it everywhere because maybe the type is something custom, you don't want to repeat multiple types. So what I've seen people do, and I've been doing it in my projects as well, is to define smaller types, which are called with ID or with name, and then use constructs like all of or kind of one of in the final types definition. So now the device type will be much simpler now. So we can get rid of all of that and use something like all of. So all of, and that would be an array. So these properties, all of, one of, what else, any of, are really powerful for defining your OpenAPI schema. They let you compose your types in really beautiful ways and kind of make the repetition appear less in your OpenAPI schema. But let's focus a little bit more on our ULIT type, because I'll show you something really cool here as well. As I mentioned, we'll be using ULIT format for our IDs. And if you haven't worked with ULITs, they're really great, lexicographically sortable identifiers. They look similar to that, probably already seen that. So 26 characters. Again, sortable, can be converted to Postgres UIDs and vice versa, and really performant. Well, just a small introduction, but we'll need to define it here. So the type is, for now, is string in terms of the JSON type, right? And min length is 26, and max length is also 26. ULIT type is probably defined in some sort of internal or external Go package, so we don't want actually it to appear as a string when we generate our specification. What we can use here instead, we can use this x dash something properties, which are called extensions on OpenAPI schema. They're not exposed to clients, or maybe sometimes exposed. They're kind of internal, right? They don't change how your API works. They can be used by generators, maybe by your internal tools that work with your OpenAPI schema. So there you can come up with any x dash property as you want. And here what's really cool, we can do x go type and type our type, right? Could be maybe something else, but we'll be using the ULIT package that's already available. What we also need to tell is which package exactly, right? So the import, I believe it's xgo type import. So here's our schema for a very simple API with single endpoint. And as you can see, it's already 73 lines, which is not that bad, obviously. We can reuse these types in the future, but I've seen really huge OpenAPI specifications, 50,000 lines of them. And I mentioned that you can split them into multiple files. And I wanted to show you how to do that on one really nice example. So you can go to Google Maps on GitHub OpenAPI specification. Right, so you see they have folders, and for schemas there would be kind of maybe a file for each type, which is really great. You can combine it together, but not always easy because, as I mentioned, not all tools can work with multiple files. So they still expect this OpenAPI.yaml as a single file. So in this case, Google Maps uses some generator internally that kind of combines all of that, maybe does some deduplication and then puts into a single file. Yeah, another example is GitHub. You know, OpenAPI is so popular that big companies like GitHub expose their whole OpenAPI specification of their API because, you know, they're a public company with public API. It's in this repository. And yeah, there are YAML files, JSON files, and they're actually really big. GitHub API is huge, so you can see 8 megabytes. I won't try to open that, but you'll open this same schema. So sometimes really important to know if it becomes big, how to split it into multiple files. And there are some command line tools that can bundle multiple files into one. For example, Swagger CLI can do that. It's unfortunately in public archive, but it has a bundle command that can take multiple YAML files and create a single OpenAPI definition. Some code generators can do that as well. So we didn't go through the full specification, but we covered the most important and used properties here. And you can take this knowledge and create your own endpoints from that. And I believe now it's time to actually put it into the test and generate some Go server from that, and maybe then in the future some client code. OpenAPI standard is so popular that there are so many tools around that, and sometimes it's even hard to navigate what you need to use for a specific language or framework or use case. There is a great website called openapi.tools where you can see tools, obviously open source, grouped by different categories. So auto generators, server generators or client generators, right? Implementations, and the list is huge. And for Go, the most popular at the moment is oapi-codegen. Let's install that and play a little bit. So I guess we need the latest version, so that can be installed with go install. What's cool about this tool is that it can generate Go code for different web frameworks that are used in Go, such as Gene, Chi, Echo, few others. It generates all your types, obviously, and server interfaces that we have to implement. So it's really powerful, easy to configure. You can provide command line arguments, or you can, again, use YAML to configure your generations. We'll create a new file, kind of oapi, let's say, codegen.yaml. And then there is a whole section, what to generate and how to generate. So let's go into that. There are two types of servers Codegen can generate. There is a strict service and non-strict. The strict one will handle your input parsing for you. That's really powerful, kind of will reduce the amount of boilerplate code in the server. So I prefer this format. Really handy as well when we use ULITs for our in-path parameters or strings, so it will just make sure then, if your OpenAPI schema says device ID is required, it will be actually required and you don't need to do this validation on inside your handler. So let's go into the strict server true. And with this file, we can actually pull our oapi-codegen, which we just installed, provided a config, which is what we did, oapi-codegen.yaml, and the path to our specification, which is openapi.yaml, right? Cool. I mean, as you can see, there is a warning here. And that's because at the moment, oapi-codegen Go library doesn't support the latest 3.1 specification, which is sad, but yeah, we can switch back to 3.0 or just ignore this warning. Right, so there is nothing specific I'm using here. Obviously, switch back if you want to, just ignore the warning. Now let's explore what was generated for us. Right, there is this file, generate Go tidy, so we don't see these errors. Yeah, because right now we have these new packages that's been added. It says don't edit this file, which is true. Never edit these files. Edit the specifications first and then go to this file. What we can see here, the types are defined for errors for our actual types, for ULITs. You can see there is a link to oklog ULIT package with ID, with name. What's interesting is that there are two interfaces here. So let's look for that. Oh, sorry. Right. One is just a server interface. As you can see, it has a device ID here with handler. It has a wrapper over that. And there should be another one, yeah, strict server interface, which is a little bit different. It has some parsing happening, and it also uses this specific types for request and response, which are really handy because they also have, pre-generated different types for all possible responses. So for a 4, for 200, which are really handy then to use in our handler. And that's it. It's actually quite a short file for our API because our API is very easy. What we need to do, because again, it's an interface, right? We need to implement exactly this interface. And I hope you understand Go a little bit. And in Go, interfaces are basically a collection of functions that you have to implement in order to satisfy the interface. So very easy to do in our case, just a single function. So let's do that. We can create a new file where to put it. Let's also do in the package API. Let's call it implementation.go. We'll use our device type that was generated for us, some ID. Again, it was ulit, so we can do ulit. I believe it's .make is a function for that. As you can see, it imported our OKLog ulit, and there was a name and test device. Obviously, your real API implementation will be different here. For this example, that's enough. We always return a 200 at the moment, but you could handle the errors here and do something else. But for us, it will be as simple as return. I believe it's get device. There is a 200, which actually is an alias of a device. So you can do something like that, and no error. This approach is really handy because you have this file implementation.go or multiple files when your API is big, and you only focus on the implementation. You get the request and you get the response. You return the response, and all the types are pre-generated for you, so really easy to work with. You can reuse the types that you already have in the system using xgo type. So like we use for ulits, maybe device is already defined, so you also don't want to create it again. You can refer to some existing type. So this is quite cool. Now, what's left for us is to actually run this server. Remember, we use Echo as a framework. For that, we can start in the main.go file. And now we finally can start our server, which is start. Let's do this 880. You probably also want to somehow visualize your API documentation. Maybe for some teams, YAML is just enough as is, but there are again many tools that can help you with. And Swagger, being really close to OpenAPI specification, has the Swagger UI, which is a kind of well-known tool to visualize things. There are Docker versions, there are some tools that can help you generate this code, but the easiest at the moment is just to take the unpackaged version, which has this unpackaged URLs for, I believe, CSS and JavaScript. So we can just and put it somewhere, maybe again in the API index HTML, right? URL should be different, so let's Swagger OpenAPI.yaml. And to do that, we're going back to our main.go file, and we can use something like go embed, which is really cool. So we'll do something like here, Swagger UI. I believe it's embed right.fs. So if we hit /swagger package API, we'll kind of open this index.html file. And if we hit /swagger /OpenAPI YAML, it will basically show this YAML. And yeah, we need to strip the path where to find it in this file system. So that's how we do it. Run, and go more tidy maybe as well. There is nothing new. So go run, just use dot. Hope it all works. And we should see the framework, the Echo lab stack. As you can see, our HTTP wrapper already did this validation for us. So we didn't write any of that ourselves, but you can already tell that something in the query is not valid ULID, which is cool. Let's get the valid ULID from somewhere. I hope there is somewhere an example, because I don't know how to generate one on the fly. Go back and hit something like that, and we get our test device, which is always the same. This ID was generated on the fly, so it will be different each time, as you can see, right? And it's lexicographically sortable. Okay, now we can go to localhost 8080, I believe Swagger, and then, all right, Swagger API index.html, and see our Swagger UI here. The servers that we defined previously are in this list, so we can pick maybe from public servers, which is not really necessary. It will kind of use the one that's currently running, I believe. And yeah, there's a single endpoint, as well as all our types and errors defined here. And we can call it directly from here as well. Cool, yeah, and we can see our response here, which is quite handy. You know, you ship your API together with the documentation. So that's how can you include Swagger UI inside your Go application, which is not always needed. Sometimes teams use Postman. It's also good to mention that it's possible to import your OpenAPI specification into Postman. Either JSON or YAML format works well, so you don't need to go and use Postman UI and manually define all your endpoints, which I've seen people do something like that as well. As mentioned earlier, the big power of OpenAPI is that you can share it easily between teams. You don't need to share the implementation itself, but rather the spec. And yeah, let's imagine the use case where the server API is written in Go, and then there are clients in TypeScript, which is really popular nowadays. Again, you can go back to this openapi.tools webpage, unless you already know the tools, right? And search here for TypeScript. And there'll be really a lot of, you know, auto generators, code generators, server client generators, many tools, right? And there are many popular ones. The one I've seen being used very often is OpenAPI Generator CLI, which can be installed with npm, but it's actually a Java tool. Yeah, it kind of sounds weird, but yeah, you can install it with npm and then get an error that, you know, Java JDK something is not installed. Yeah, but this tool is really great because it can generate different TypeScript clients. Let's go and generate some client code for our API. Cool, so where's the installation part? I guess here. Yeah, and that's how it will look in our case. So input file, OpenAPI YAML, the folder where to put it, and then TypeScript fetch. You can use something else here, but let's go with this thingy. Awesome, there is some output log, and I believe it worked just well. So let's go back. And now let's just first explore this folder, because there are multiple files actually here. In the models, you will see the TypeScript file for each type. So it's not in a single file like Go has. Let's go in the APIs. That's actually quite interesting. This package kind of combines these endpoints into the APIs. I'm not sure how they call interfaces or modules. So you can import it, kind of device API, and then call device API.getDevice. So let's see. Yeah, that's getDevice row. Yeah, I believe this async function getDevice. So kind of import this device API and then do .getDevice and then provide the ULID, for example, and then get a response. And that's it for today. OpenAPI spec is a de facto standard at the moment for designing, implementing, and consuming the APIs. You've seen how many tools are built around that and how popular it's becoming. You know, GitHub exposing their OpenAPI spec for their APIs, etc. I believe it's really valuable to understand how it works, and I hope this video gave you a little bit of introduction on how to use it, some tips and tricks specifically for Go, obviously, because that's the topic of our channel here. I'll leave the helpful links in the description as well as the full source code for this example. Thanks for watching and see you later. Bye.